This is an introduction to conic sections, and in order to do that, I would like you to do this warm-up, and we'll pause just a minute if you'll hit the pause button. Solve these for y. Okay, you'll notice on the first one when you solve for y, you move the x squared over first and square root it. Notice also that it's a plus or minus when you square root the y squared. The reverse of squaring is square rooting. You get 2 square roots. The second one, we move the negative 4x squared over to the other side. Then we divide by the negative 9. Then we square root it, and we get plus or minus the square root. Now the 9 had a square root of 4x squared minus 1 over 3. Our objective today is to recognize the conic sections as intersections of planes and cones. Use the distance and midpoint formulas to solve problems. You'll notice here a series of conic sections. What are conic sections? Well, they're sections of cones that are formed by the intersection of a double right cone and a plane. There are 4 types of conic sections: circles, ellipses, hyperbolas, and parabolas. Although the parabola we spent a lot of time studying in chapter 5, their functions, most conic sections are not functions. Think of a circle. A circle here cannot pass the vertical line test. The ellipse, look at it. The ellipse is called the elongated circle. It can't pass the vertical line test for functions. Parabolas can if they're opening upward or downward. They cannot be if they're opening sideways. Hyperbolas cannot be because if you put a vertical line down here, that will fail the vertical line test. Notice that when you take the square root of both sides of an equation, that means you must include the positive and negative roots. Graph each equation on a graphing calculator and identify each conic section. Now, I won't have you do it on the graphing calculator, but I will notice for you that this x minus 1 quantity squared, the hk right here, that's h, that's k, change the sign on them. The center of the circle is at 1, 1. The radius is the square root of 1, so that is, again, 1. Now this is what you would do if you were solving this for y. Once again, you'll notice you get a plus or minus square root right here because you're square rooting this number. You can't pull that negative 1 out and move it to the other side until you take care of the exponent. So the reverse of squaring is square rooting. There's 2 square roots, plus or minus. Now we add 1. And that's what our equation would look like solved for y. Notice there's 2 answers, 1 plus the square root and 1 minus the square root. Now again, this is what it would look like with the center at 1, 1. And because the radius is 1, the x and y intercepts would be 1, 0, that's the x-intercept, and the y-intercept would be 0, 1. This is what the table feature would look like if you put this on your graphing calculator. You would have to put 2 equations in because 1 plus the square root and 1 minus the square root are different graphs. You can see here, here's the plus square root, it's the top half of the graph. Here's the minus square root, right here, it's the bottom half of the graph.